Hi there. This is Dr. Dell, Craig Hain, and I'm talking about the Teaching Math book. And this is the video on we call the Interlude Overview or Introduction. This book, Teaching Math, as you know, is all about how to teach high school mathematics in the 21st century using the tools and the delivery methods we have for doing that, and how it is such a tremendous advantage to our students to be able to learn in this way compared to our standard curriculum. Now, in this book, I have put 6 interludes that are really aimed at mathematics teachers to try to give them some ideas about what I do in the foundation course that they might be able to carry over into their teaching as they teach things. And so I want to talk about those interludes here and what we're trying to accomplish with them. First of all, one of the things that we emphasize in this program is that when you have a math problem, the first question you always want to know is, do I have enough information given to me to solve the problem? Because many times in the real world, you're given certain information and you want to have certain answers, but and you set up a mathematics model, and then can you solve it? Is there enough information? And two is, do I have the adequate tool or a proper tool to do that? And in fact, as you know from reading the book, I'm all about using power tools in modern mathematics. And the one we use in the foundation course is the TI-30XA scientific calculator. And this is really many, many tools built into one. It lets you do all the arithmetic calculations as you're going to do in practical math. So the interludes are about trying to get people to think about these two issues here, and also that's what we do then in our foundation course. So let's start out with a question. Suppose I gave you a triangle. Now triangles are arguably the most important polygons. They're three-sided, and they're the only rigid polygon, meaning if you know the lengths of the three sides, then the shape is determined, the angles are determined. And suppose that I told you that this angle was 50 degrees and that this side's length was 27 inches. And then I said to you, what is the area of the triangle? And we'll often do this with students. Well, if you look at it and think about it, pretty soon you'll realize that you do not have enough information. One side and one angle just isn't enough information. And one way you can easily see that is you could take another triangle that looked like this one, where that was a 50-degree angle, and these were the other two sides, and clearly that triangle has a very different area than this one. It's a much larger area. So you don't have enough information. Okay, what else would you need to have in? Well, let's say that I told you that this side over here was 12 inches. Now do you have enough information? Well, if you go to your standard geometry class and look at 1/2 base times height, and that's the only tool you know, that's the only formula you know, then the answer is no, I still don't know how to solve this problem. And you would not find this problem in a typical geometry text. But we believe that because this is a practical math foundation, you should begin to teach students that there are going to be formulas to solve this if you have the right tools. And so the formula that we give people is we say, we'll start with these two sides and multiply them together, and multiply that times 0.5, and now that would be the area if this was a 90-degree angle, because then this would be 12 would be the height to that base. But now we need a correction factor, and that will give us the area. And the question is, could we come up with a correction factor? Now it turns out that we can, and that's what we teach. We'll start out with 0.5 times 12 times 27, and if we hit the equal sign, we have 162. But that's not it. What would be a correction factor? Well, it turns out, and this is what we teach them then, if you take this included angle, 50, and take the sine of it, the sin of it. You may not know what that means. It's a key on your calculator. And hit it, and then hit equals, and then multiply that times the what we already had was 168. You're going to get the answer, the correct answer. So let me do that again quickly. You take 0.5 times 12 times 27 equals, multiply that times, now take 50, take the sine of 50, and then hit equals, and you get 124.1. Set that to 1 decimal place, and that would be the answer. Square inches, if these were both inches. And so the correction factor turns out to be the sine of that angle. And that's what we talk about in the first interlude. And that's what we teach in the geometry foundation. We give them this correction factor in the formula for the area of a triangle so they can use it. Now, we do that for two reasons. One is we can start solving certain triangle problems already in geometry. And it also is a motivation to say, well, gee, maybe these functions up here have some value. They're called trig functions, and we haven't taught them trig yet. They don't know what it means, but they see that at least there's one use of it as a correction factor. Well, then later, when we go into trigonometry, we give them another triangle problem. We say, okay, suppose you've got a triangle here, and you've got, let's say this is a 70-degree angle, and this is a 25-degree angle, and let's say you know that this side over here is 53 in units long. These are degrees, these angles, and this is, say, inches. What's the length of that side? Well, we learned with similar triangles, if you can set up ratios, you can solve them, but there's only one triangle. So what we teach them here is if you take L over 53, that's going to be equal to another ratio. Now we start out and we say, well, would it be 25 over 70? Would that work? After all, you know that L is going to be shorter because 25 is smaller than 70, so L is going to be shorter than 53. Would that ratio work? And the answer is no, it doesn't. But then we learn that if you take the sine of 25 and divide by the sine of 70, that does work. And so now they can easily solve that problem, and this is the so-called law of sine. So we take 25 degrees and we take the sine, and we divide and we take 70 degrees and take the sine, then we hit equal, and then we multiply that times 53, and bingo, 23.8 is this length. And that's what's called the law of sines. Then the last problem we give them in the foundation course, and it's the last thing that we cover in trigonometry, is we give them a triangle like this. We say, suppose you have a triangle, and it has sides 3, 4, and 6. Now, you've seen me ask this question before, because it's kind of my one question test that I give people, and I ask, what's the area? Now, if you knew one of these angles, you could answer it the way we did it already. You take this times the sine of that, times 0.5. Well, we just learned that. We learned that back in geometry, but you don't know any of these angles. All you know is the sides. Now, these angles are determined by the sides, but we don't know what they are. So then we teach them to use what we call the generalized Pythagorean theorem. If this was a 90-degree angle, you could easily do it, but it's not. So we teach them how to first find this angle with the generalized Pythagorean theorem. And I'm not going to, it's called the law of cosines as well, and I'm not going to elaborate on it now, but let me just show you how a student then would solve this problem and how quick and easy it is if you've got the power tool. Now, if you have to do this with pencil and paper and old-fashioned ways, this would be a much, much harder problem to do. So let me show you how easy it is and how the students learn to do it. We take 3 squared, which is this side, plus 4 squared, that side, and we subtract 6 squared. And that would be 0 if this was a 90-degree angle, but it's not. So then we have to divide by 2 equals, divide by 3 equals, divide by 4 equals, and now we get a number here that will be the cosine of this angle, and if we take inverse cosine, we get that angle. It's 117.3 degrees. And now that we know that angle, we take the sine of it, then we multiply that times 0.5, multiply that times 3, multiply that times 4, hit equal, and there's the answer. I'm going to set this to 2 decimal places, 5.33. So the answer is 5.33, and that's a problem that you've seen me give many times, because I give that as a one-question test. If a person can get the area of this triangle to this degree of accuracy quickly, then they probably know enough math that they're not going to learn too much in the foundation course. They'll learn something, but not as too much. But very few people can do this easily. It's not an easy problem to do if you don't know how to do it. Now, we always encourage students to check their work. So often what we'll do is we'll say, okay, now let's come up here and let's do this a second way. Well, in fact, let me do it down here. I know that's the right answer for that one because I've done it enough times I remember, but let's make a new problem up. Let's take a triangle like this. And let's make that 125 degrees. and let's make this 8 inches, and let's make this, oh, I don't know, 12 inches, and actually I don't need to know what that is. Let's make 8, 12, and let's make this, let's see, 20, I want less than 12, let's make this 17 inches. So there you have 8, 12, and 17. What's the area is the question. And by the way, I don't know what this angle is now. So what is it? What are we going to do? Well, I'll use these two sides to do it. So let's see how quick we can do it. We're going to take 8 squared. I didn't do that right. Let's start over. We're going to take 8 squared plus 12 squared minus 17 squared equals, we're going to divide by 2, equals, divide by 8, equals, divide by 12. See how easy this is? Equals. That's a number. If we're going to take the inverse cosine, that'll be this angle, which is 114.95 degrees. Take its sine, multiply that times 8, multiply that times 12, multiply that times 0.5, and the answer should be 43.52 square inches. If these were inches, it'd be square inches. If these were feet, it would be square feet. Now, we always tell people, check your work, do it twice. If this is an important problem, if you're a carpenter or you're laying out a landscape or whatever, you always want to check your work. So to see how quick this is. And students learn to do this. If you've done this problem, if you've done 10 of these problems, you get just this quick at it. It's very easy and quick to do. So we'll take these two sides. So we're going to take 8 squared plus 17 squared minus 12 squared equals, divided by 2, equals, divided by 8, equals, divided by 17, equals, and that'll be the cosine of that angle. Take inverse cosine, and that's going to be 39.8 degrees. We're going to take the sine of that, times 0.5, times 8, times 17, and if there's any justice in the world, that'll be the same answer, 43.52, and indeed it is. So we've done it two different ways now, using the generalized Pythagorean theorem. I call it that. And it's also called the law of cosines. And that's the last topic we teach in foundation. So what's the point now? The point is you want to motivate as you go. You want students to understand that they can't do this problem until they get this generalized Pythagorean theorem. At least they can't do it in some easy way. There are other ways to do it, but they're more difficult. Or this problem. So you want them to know what can they do. It depends on what they know and depends on what tools they have available. In this case, you needed to use both the cosine and the sine to solve this. In previous cases we looked at, you only needed to use the sine. Now the fourth interlude is where I discuss the sphere. This is a very interesting thing. A sphere is like a ball, and if you know the radius, the question is, what is its volume and what is its surface area? And quite frankly, that is extremely difficult to derive that from first principles or to prove a formula. And therefore it's hard to remember a formula if you can't easily derive it. But it turns out it's related to the sphere with which it's inscribed. So if you take the cylinder it's inscribed in. So this would be radius r, this cylinder, and this height would be r plus r, be 2r. And it turns out it's very easy to do the volume, let's say, of the cylinder. You take the base area, pi r squared, times the height, which is 2r, and so you get 4 pi r cubed, and that's the cylinder. And then what Archimedes discovered was the sphere's volume that's inscribed in this cylinder is exactly 2/3 of it. So if you multiply this by 2/3, you get the volume of the I'm sorry, this was a 2 up here. You get the volume of the sphere, and this is 2 times 2 over 3. This is 4/3 pi r cubed, and that is the formula. Now, it's hard to prove. In fact, we don't prove that until we get into tier 3, and we give another proof of it, a deeper proof in tier 4. We don't prove anything in foundations. We just learn how to use the formulas and apply them. Now, the last interludes that I give you are about complex numbers, and those are things that we don't cover until we get into tiers 3 and 4 in our program. But it's something every high school teacher ought to know, and we ought to be teaching them in high school. So I would certainly encourage you to at least read about those interludes and get some ideas from it, and begin to teach complex numbers in your high school math. So that's what these interludes are about, is try to help you improve as a teacher or at least supplement what you're doing. We can always improve. I don't care who we are, we can always improve. The Japanese call that Kaizen, continual improvement. So I hope these ideas will help you do some things in your teaching that will then in turn help your students. So this is Dr. Dell signing off, and I'll see you on another video. Bye-bye.